Next, I'm going to show you what are the commands supported by this ultralight tags. So within the document, expand this command set node, and you can see it has got REQA. So guys, these are the only commands that are supported by this ultralight tag. So every tag has got their own set of commands. So REQA, W called WUPA, WPA, and followed by got cascade level 1, cascade level 2. We have already seen REQA. This we have seen anti-collision and select commands. We have seen it, but and also we have seen the read. And what you have not seen so far is the WUPA, the halt, and the compatible write and the compatible write. They are really interesting. Now let's go through this command. Just go through this, understand what it is. So the first thing is REQA. So I'm not going to read out because this document is right in front of you or you have a copy. So what the most important thing here is, as you can see here, the code for REQA is called 26. There's something after it says 7-bit. So it means the reader must send the 7-bit, even though we always speak about a byte that's going out of the reader, whereas in this case REQA, it is 7 bits. I have read some information about why it is 7 bits. I shall leave that to you. Just browse internet, get why it's 7 bit. Okay, and as you can see here, the integrity mechanism is just a parity. The parity is automatically taken care of by the reader writer chip, in this case CR95HF, and the response you expect is 4400. Again, there are documentation that explains what is this 4400, and this is where this diagram is very interesting, and I think this is something you have to understand as well. So the reader sends 26, and say after some time, we'll not worry more about this timings here. After some time, the tag returns 4400, and just quickly go through and see what it is. And keep in mind here, we don't see anywhere the CRC, because every time you read about a reader writer, there is a mention about CRC code send as well, whereas here there is no CRC, just a parity. Just quickly go through the tag and just we'll just quickly say that we are sending 26 and we are getting this 4400. So I'm not going to activate again. We already have this activate tag here. It's 26 and 07. See, this is where all the magic is happening here. 26 is the command. 26 is the command for REQA. The 07 is the command for the CR95HF, and this 07 tells that it should send only 7 bits, not the 8 bits. So I'm going to quickly show you where exactly you find this information about 07. So you have to open this document on CR95HF. This is the data sheet you can download from the manufacturer website, and the command that is used to send the data to the tag is the send and RECV command. And this is a nice explanation here as well. And in fact, the example that is shown here refers to REQA. See, the last byte of this command is called as the transmission flag. So here we have got 8 bits. You can see this, the last 3 bit, this says it speaks about a number of significant bits in the last byte. So in our case, so let's put the data, the value of the last byte, it is 0111. It is a 07, isn't it? Now if you compare this, the last 4 bits here says it is only 7-bit, and there are so many other things. The other important information here is the append CRC, and I've never used in other bits. Okay, Just one more information before I close this. You will also see a command that ends with the 28. Probably I thought explain that one here as well. So if the command ends with the 28, let us get this bit pattern for 28. Okay, and we know that this 4 bits says the last byte, it has got all the 8 bits, followed by we're not worried, followed by this bit corresponds to the parity. We'll not worry about that. Look at that, this bit corresponds to this append CRC. So whenever this bit is 1, the CR95HF will automatically include the CRC along with the command when it sends the data to the tag. So the next command is not UPA, we'll come back to that in a bit. The cascade level 1 command and the select command here. So if you look at the document, the code for anti-collision is 93, and it can any number from 20 to 67, and this is followed by the part of the UID. Actually, it's not that, sorry, this belongs to next command. Okay, so let us see here. The anti-collision 1 or the anti-collision at level 1 is 93 and 20, and as you can see here, the documentation doesn't speak anything about the CRC. Okay, so nothing is sent here, and the tag will respond with the number 88, which is called cascade tag, followed by the 4 bytes. So in other words, the tag responds with the 5 bytes, where the first byte is the CT, followed by the first 3 bytes of the UID, and followed by the BCC1. So as you can see here, there's a timing as well. I know, as I mentioned before, it's not very much required. I never found this timings useful for me or for the work I do. And the output, let's see if this yeah, that's it. Okay, so the anti-collision command will return you part of the UID, and let's see that we are using 9320. Now if you go back here, so this time the documentation doesn't say anything about using 7 bits. So look at this anti-collision 1 command. You got 9320 followed by 08. So 08, it means the 8 significant bits and no CRC, and the response you get from the tag is, the document is say 88 followed by the 5 bytes here, and there is all these responses. You also have 3 additional bytes here. I'm going to speak about that later. These are called as the control bytes. So we'll see now how to decode these 3 control bytes. So I just came to know when I made the video on anti-collision thing. I never knew about these collision or these control bytes. I just mentioned that it's something to do with extra bytes or CRC or something like that, but now I know exactly what these 3 bytes are. Again, you just have to refer the documentation. Now this is fine, so we know that it's 9320, and we got this as a response. The next thing is select 1, because all these are happening at the level cascade level 1. I'm going to call this as select 1. So the select 1 will have 93 followed by 70 followed by the 3 bytes of UID, and as you can see here, the command expects parity, BCC and CRC all together, and the outcome of the select is SAK. Here again, it's just a 4 bits. I'm going to tell that. Okay, if you go here in this document here, so this is the command, this is the raw data sent by the reader, and you can see here it has got 937088. All the thing it has received from anti-collision command needs sending it, plus the CRC, and the output is, this is interesting here, you get 04 again it is followed by the CRC as well. So here the SAK, some in the documentation is mentioned that the SAK is just a 4-bit number, it's not a full byte, just a 4-bit. So let us see how this is done in our software. So select one command, we have got 9370 again. Okay, there is a 70 here, there is a 20 here. So they're just not any random number, because if you look at the ISO 14443 part 3 documentation, it says the 70 means it's a full 40 bits of data, and 20 means no data is sent, and everything up to here. The interesting bit is the last two, 28. I mentioned this before. 28 means generate CRC, and also the last byte that is going here, that's 42, basically telling that send all the 8 bits of this byte, whereas here send only, see, this number refers to the last byte. So here we are telling that send 26 or 26 as a 7-bit number. So here what we have got is the select one, you got 04 followed by the CRC, followed by this something, this time it's 0800, whereas if you remember we used to get 2800. So these 3 bytes are the control byte, and this is a positive SAK is it's a successful acknowledgement. So 04 is a success. So next command we are going to see here is the cascade level 2 anti-collision and select command. So here anti-collision is the command is 95 followed by some number 20 and part of the UID, and there is no CRC here, and this is the structure. So the reader sends 9520 and the card returns you the remaining bytes of the UID followed by the BCC, and again there is the response does not include any CRC here as well. Okay, you can see here there's no CRC in this tag, and let's see how. So we don't have anti-collision 2 here because we took a different path. I'm going to clear this time, choose the ready one. Oh, sorry, you need a full normal one. Just clear it. So yeah, so anti-collision 2 here says you're sending 9520 followed by 08 is the transmission flag, says that the last byte is sent as a 8-bit number, and the output of that is the remaining part of the UID, and it's also got probably up to there's no CRC here, as you can see. 72 E9 33 and 82, these are all part of the, one second, wait a minute, 82 and followed by the BCC. Okay, up to here. So this is the remaining part of the UID, followed by 280, this is a control byte, and there's no CRC here as well. And next we got the select 2. The select 2 command, it's a 9570 followed by everything we received from anti-collision 2 followed by CRC, and the output here will be 00. So this is a positive SAK followed by the CRC. So here we are sending 9570 followed by everything. Again, that I'm repeating here again. So 28 means send CRC, and the output is got 6 bytes. The response, the 80 is a success. Sorry, I should have mentioned it before. 80 is a success everywhere, followed by the number of bytes in the response. This is 6 bytes, and this is what the 00 SAK means. Okay, the SAK is 00 followed by the CRC followed by some control bytes. Okay, and all these commands, REQA, anti-collision, they are all called as anti-collision or activation commands. The next command to understand is the read command, and this is the command we use to read a page of data. That's a 16 bytes, and you got the command code here and parameters. I think it's easy to understand the command structure from this diagram here. So the reader must send 30 followed by the address, address the page number from 0 to 15, followed by the CRC, 2 byte CRC, and what you get in response is the 16 bytes. So here, starting from the given page number, you get the remaining additional 3 pages as well. So say for example, if you request page number 1, you'll end up getting data from page number 2, 3 and 4. All together you'll get 16 bytes, and followed by zeros, the CRC. If there's any problem reading, you'll also get a NAK, and NAK there is a code somewhere I'm going to show later. So let's see how the read command is done. So because we are playing here, we don't have the read command. I'm going to hit this. You can clear. I'm just going to hit this read tag. So look at this tag here. 30 is the command followed by the page number followed by 28. So again, it says the 8 bits and generate CRC, and this is the content of the first 4 pages. So here 80 is a success, 15 is a 21 bytes altogether, and starting from here up to probably here is the data, and followed by 4 bytes of UID followed by 08. This is a very positive control bytes, 08. Likewise, because when you hit this read tag, the entire the tag is read. So I'm reading next from page number 4 onwards. You get page number 4, 5, 6, 7. So again, okay, this is so same thing, this whole thing repeats here. So this is how you read the data. The next is the write command. So the write command, the code is A2 followed by the address followed by the 4 bytes of data. So bear in mind, you can write only 4 bytes of data at a time. Even though read returns 16 bytes, you can write only 4. So I think there is no diagram here. Sorry, let me check. Yeah. So here, I don't know if the diagram missing something here. So here you have to send A2 followed by 4 bytes plus the CRC. Let me check. Okay. There's some information here as well in the summary. So SAK 04 in case of anti-collision 1, SAK 00 in case of select 2. So let's go and see the write. So I'm going to show you how to write first to the user memory. So in this software, I'm just going to click on the page I want to write, and you see the corresponding data here. Let me write say 1000 or 10,000. So the 10,000, the hex number is this. I'm going to clear so that we have the logs. Now I'm going to write. Now I get write is successful, and if you look at this, what I'm doing, exactly what document says, A2 followed by the page number 04 followed by the 4 bytes of data followed by 28. See, 28, I'm just repeating this again. See, 28 is not part of the data. It is the additional data we're going to send to this DLL. And what you get as output is the SAK. See, there is no the output is very straightforward here. It just says 04. It says, it is, sorry, I was wrong, sorry, it's not output 04. It's 04 is the number of bytes here. See, the output is the positive acknowledgement. It's 0A is the acknowledgement. This time the control bytes are something different. It's a 240000. So this is very interesting to know what exactly these control bytes are. But keep in mind, when the write is successful, you get a 0A as a success code. You can keep writing. I've got this section that I can write multiple pages at a time. Assume that I want to fill this data with the, say for example, let's fill this with the Ultra or Mifare Ultralight UL. So this is the hex code of that. Say write from page number 5 onwards up to 15. Write. So all this data has changed. So there's anything special here. I just had to issue a series of single write command for write 5, write page 6, page 7, so on, and just keep in mind this response code 0A. So that is how the write command works. And all other things, for example, I'm going to explain how this locks, and the first is a lock. And keep in mind, locking is like a one-way ticket. Once you lock the memory, you can never ever unlock it. That's a good thing about these ultralight tags. So I can write some kind of for example, the customer name or some identification data here, and I can just permanently lock it so that it can never ever get changed. So, or you can use this to write some kind of like a encrypted data or anything. Okay, so what's more important here is this card, the ultralight tag, has a feature to lock the memory. So probably I've seen some tags where there is no locking feature at all. So that's the feature of a tag.